All right, boys and girls, so now we're going to go over Chapter 4, Section 3, and the name of this section is Congruent Triangles. So, congruent triangles, we have a definition here. This is what the book says. If two geometric figures have exactly the same shape and size, they are congruent. So let's take a look at what that means. I'm going to go ahead and put two figures up here, and I am going to identify all the corresponding angles and corresponding sides, and then make what's called a congruent statement that just says that one triangle is congruent to another. Let me get this up here for you. All right, so here I have two shapes right here, two triangles, and we've got our sides labeled. These marks, keep in mind that if you have a mark and it's the same mark on two parts, that means these are corresponding congruent parts. So that means this is the same measure as this is the same angle as this. So what we're going to do is we're going to go ahead and identify all the parts that correspond, and if they have exactly the same shape and size, they are congruent. So first thing we'll start with is corresponding angles. So corresponding, let's identify all of the corresponding angles. So first of all, I know that angle A, which is right here, see how it's got two marks for that angle? That's going to correspond with angle H that also has two marks. So I'm going to say this is congruent to angle H. And next I'm going to say angle B has one mark, is congruent with angle J. And angle C, 1, 2, 3, congruent with angle K. Next, let's take a look at the corresponding sides. Well, I've got side AB, and this is how we draw a side. We write the letters, put a little line over top of it. So AB is this one right here, has one mark. That's going to be congruent with HJ right here. Now, before we go too much further, the order is important. I can't write AB is congruent with JH. It should be this way in the same order. How do I tell the order? Well, from AB, look, I'm going from this angle here with 2 to 1. So 2 to 1, and with HJ, 2 to 1. So just make sure you have that order correct. BC, I've got 1 to 3. That's going to go with JK, 1 to 3. And the last one I have here is AC. And AC, we've got 2 to 3. That's going to go with HK, which also has 2 to 3. So the next thing that we have to do is we have to write the congruent statement. Now the congruent statement, since these are triangles, we're just going to use a little shape for triangle. Triangle A, B, C, and if it was a polygon, you would just write polygon ABC, is congruent to, and again, order is important. So A has 2, H has 2. So I'm going to write triangle, start with H. Next we have B, which has 1, J has 1. And last we have C, which has 3, K has 3. So just verify that you have that order correct. So this is the congruent statement. This is how you prove it, because all the corresponding angles and sides are congruent, therefore the two shapes are congruent, and on a test this is what we would look for right here. So now let's work on some problems that have to deal with congruent parts of triangles and polygons. Alright, So here we have two triangles, and I've got different parts labeled. We've got the angles 45, 99, and 36, and this is a length of 32.1, this is 38.4, and this is 54. This is 8y minus 5, and this length is 2y plus x. Now, we also have a statement here. Triangle ABC is congruent to triangle DFE. So that means this order, so that way we can tell what corresponds. And it also means that all the side lengths and all the angles, they're all going to be congruent. They want to know what x and what y is. So I need to figure out what this angle is and what this length is. So first of all, when I look at this one, I have two variables in there. This one I only have one variable. So this is the one I'm going to attack first. Figure out what this one variable is, and then I'm going to substitute what y is into there to figure out what that is. So let's take a look at this. So first of all, this angle right here, angle F, corresponds with angle B. That means that 99 degrees is going to equal 8y minus 5. So I'm going to go ahead and set this up. 99 equals 8y minus 5. First thing I'm going to do is get rid of this constant. Opposite of minus 5 is plus 5, so I do that on both sides. This cancels, and now I have 104 equals 8y. Now, y is being multiplied by 8. The opposite of multiplication is division, so I'm going to divide by 8 on both sides to get rid of that coefficient. I've got y right here, and y is going to equal 13. So now I've got this one done. I can check it off. Next, I need to find out what x equals. So I've got a couple things going on. First of all, I know that this side, FE, is equal to the side length for BC, 38.4, because of my congruence statement. So I'm going to go ahead and set that up. I've got 2y plus x, and that's going to equal 38.4. I also know what y is. We just figured it out. Y is 13. So I'm going to rewrite this, and I'm going to substitute 13 in for y. So now I have 2 times 13 plus x equals 38.4. All I did was I substituted my value for y in for y. I can simplify this. 2 times 13 is 26. So now I have 26 plus x equals 38.4. And this 26, since there's no sign written in front of it, you automatically assume it's positive. So that's a plus 26. And the opposite of plus 26 is minus 26. So I'm going to take away 26 on both sides. This cancels, and I have x equals 38.4 minus 26 is 12.4. So now I solve for what x and y equal, and we are done. Okay, the last thing I want to show you for this lesson is something called the third angles theorem. And the third angles theorem basically says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are also congruent. Let me draw some triangles here and explain what I mean. Okay, so here I have two triangles here. And one thing you should notice right away, angle B and angle J, they are congruent. Look at the marks. I also know that angle C and angle K are congruent. I can tell by those marks. Well, here's the thing. Remember that all triangles have to add up to 180 degrees. The interior angles all have to add up to 180 degrees. So, because of that, this angle right here, let's call this X. And let's call this one right here, let's say this has a measure of Y, and this has a measure of Z. Well, I know that angle X is going to equal 180 degrees, the sum of all the angles, minus Y, minus Z. On this one right here, since angle J is congruent to angle B, I can also call that Z. This right here is congruent, so I'm going to call this angle Y. So I know this one right here, let's call this, I don't know, angle h. H would be equal to, the sum of all angles is 180, minus this angle and this angle, so minus y minus z. Notice these are the same. That means these angles are the same right here. So this angle, let's use 3 marks, 1, 2, 3, has to equal this angle, 1, 2, 3. That's the third angles theorem. If two angles are the same, the third one has to be the same.